Okay, now next we look at what is a local extremer. A local maximum or minimum occurs when a point is higher or lower than nearby point, and a local maximum or minimum occur at interior point of an interval. So this time, if I want to find what are the local maximum, and we have two local maximum. One is here, another one is here. Because at this point, the function value is higher than the function value of the point nearby, right? The function value at -2 is higher than the function value nearby -2. For example, -2.5 or negative 1.8 or -1.6. And the second local maximum is at x equals 2, because the function value is higher than the function value of the x nearby 2, right? So local maximum is um, 3, and it occurs at x equals -2, and local maximum is 2.5, and it occurs at x equals 2. Now, for the local minimum, we have only one. When x equals -1. Local minimum is -1, and it occurs at x equals -1, because at -1, at x equals -1, the function value is smaller than the function value at the point nearby x equals -1. Now, some students are confusing about these 2 points. They confuse that why this point is not a local minimum. The reason this point is not a local minimum is because we are not sure if this function value is the smaller. Why? Because we are not given any information. We are not given any information when the function value, when x is greater than 4. Because if the graph looks like this, right? If the graph goes like this way, then this will not be a lower point. So that's why when we consider the local maximum and the local minimum, as it says, they only occur at interior point. They only occur at interior point of the interval. So that's why we don't consider these two endpoints, x equals -3 and x equals 4. Okay. So here is the the formal definition. The formal definition of a local extremer. Let f be defined on an interval I, and let x equals c be an interior point. You see here, again, it says this point must be an interior point of that interval. If the function value at c, f of c, is greater than or equal to fx for all x in some open interval containing c, then f of c is a local maximum value. If f of c is less than or equal to fx for all x in some open interval containing c, then f of c is a local minimum value of f. Okay. Now, after we see the definition of absolute extremer and local extremer, I want to talk about the things some students, the kind of mistake some students tend to make. That is, they are not sure. Okay, they are not sure what answers they are expected to put. So when the problem asks for what is the maximum or minimum values, your answer is supposed to be the y values. So if we ask for the maximum value, your answer should be the highest y value. If the question asks for the minimum value, your answer should be the lowest y values. But if the question asks where does the maximum or minimum value occur, then your answer is supposed to be the x values. Okay, let's look at this example. A function is defined on the closed interval from 2 to 7. Okay, now we want to find what is the absolute minimum value of this function. Okay, since I'm looking for the absolute minimum, that means I'm looking for first I need to find where is the lowest point, and that is here. The lowest point is here when x equals 4, right? And because here we are asked to find what is the minimum value, so the answer should be the y values, and the y value of this point is -3. So the answer is -3. Now the next question, where does the absolute maximum occur? Okay, since this question is about the absolute maximum, I find the highest point. Okay. And because the question asks for where does this absolute maximum occur, so the answer should be the x value of this point. So that is x equals 5. Okay. All right. Let's look at some other examples. Okay. So to find the local maximum of this graph, so the local maximum is here. So they are all local maximum, and the local minimum, they are here, and here. And now the absolute maximum here is the same as the local maximum. And the absolute minimum is the same as the local minimum. This is because their y values are the same. For all the maximums, their y values are the same. And for all the minimums, their y values are the same. Okay. For this one, the local there's no local maximum. Why? Because the graph keep going up, and but there is a local minimum, which is here. And it's the same. There is no absolute local maximum. There's no absolute maximum, but there is a absolute minimum. Okay. For this graph, there's a neither maximum nor minimum. Because the graph keep going up and keep going down. Okay. And for this graph, the maximum, there's no maximum, but there is a minimum. So minimum is here.